of negative pi fourths. So this is positive pi fourths, but we want to go negative pi fourths. So remember yesterday, we learned kind of a little easy way to look at it. That's 2 tick marks up, right?
Yep.
So that's the same thing as 2 tick marks down. So this is negative pi fourths right here. So we're looking at those x, y points. We know that cosine is x, sine is y. So we would say cosine of negative pi fourths is equal to the square root of 2 over 2. And sine of negative pi fourths is equal to negative square root of 2 over 2. All right, any questions on that? So isn't 7 pi fourths coterminal angle with negative pi fourths? Because it lands in the same spot, right? So sweet. All right, good job. How many got it right? Nice job, guys. Way to go. So today we're going to get started right away with the sine function. So today we're going to be really focusing in and only focusing on the sine function. So we're going to be looking at not the unit circle, but in an aspect we are actually looking at the unit circle, but we're going to be looking at it differently on a graph. So once again, remember a couple things about sine. Sine is our y values, right? Mm-hmm. So as we go around our unit circle, we're focusing on our y values. So let me show you how a sinusoidal wave is formed. So at 0, at point 0, does everybody see how this is at point 0? At 0, we're at 0. Does everybody understand that? For sine. So at 0, we're at 0 on the sine function. Then we go up, we start traveling upwards, upwards, upwards till we hit 1, right? So this sine wave's traveling upwards, upwards, upwards till it hits 1. Does everybody see that? Now once we hit the value of 1 on our sine function, we start going downwards, 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 downwards till we hit 0. Does everybody see that? Yeah. So we've hit 1, we're going downwards, downwards, downwards till we hit 0. Does everybody see that? Yeah. Okay? So then we're going down again, down again, down again, down again till we hit negative 1. Is everybody seeing it? So we're going down. I kind of drew it fast, but we can fit it. Down, down, down. So we hit negative 1. Does everybody see it? Then after we hit negative 1, we start traveling upward, upward, upward till we hit 0. Does everybody see that? So we're traveling upward, upward, upward till we hit 0. And that's how the sinusoidal wave is formed. All right, so I'm going to kind of extend this out just because, yeah. So we hit 0. So now I'm going to kind of fill it in. So we're just looking at our unit circle, but as a sinusoidal wave. Because couldn't we go around the circle again? And won't that same thing happen? Ding, ding. Can we go around the unit circle again? Ding, ding. Does everybody see how the sinusoidal wave is going? Okay, sweet. So now we're going to fill this in a little bit. So on our x-axis. Okay, so we were at 0, 0. So this is 0. And at, I'm going to change to green here. When we hit 1, what x value were we at? What value were we at for sine? We were at pi halves. So when did we hit 1? At pi halves. So right here is pi halves. Do you see how our sine function hit 1 at pi halves? Okay, then we started traveling down after pi halves, and we hit 0 at pi. Do you see? So we hit 0 right here at pi. Then we started traveling down after pi, and we hit negative 1 at 3 pi halves. So we hit negative 1 at the value for sine, the x value for sine of 3 pi halves. Then we were traveling upwards till we hit the value of 0 at 2 pi. So we hit 0 at 2 pi. So now understand, we can fill this in however we want it, because between 0 and pi halves, there was pi 6, pi 4, pi thirds, right? So in between there's all those values, right, everybody? And in between pi halves and pi, between this, we had all these, 2 pi thirds, 2 pi fourths, 5 pi sixths, right? Does everybody see how we can fill this in as detailed as we want it here? Okay, sweet. Okay, with that being said, does everybody see how sinusoidal waves are formed? We're all good. Now we can start practicing some things. Okay, so here we go. It says use the diagram. So we're really looking at a unit circle, but we're looking at the sinusoidal wave. So it says use the graph of the sine value to find, use the graph of sine to find these values. So we want to know, using this picture, not our unit circle, which this is the unit circle, but this is just the sine of the unit circle, right? This is just sine of unit circle. We're going to find these values. So 3 pi halves. So 3 pi halves, what's our function at what y value are we at 3 pi halves?
-1.
-1. So sine at 3 pi halves is equal to -1. Does everybody see how I got that? Are you sure? You're all good. Okay, sweet. Now it says, what is your value at 7, what's your sine value at 7 pi fourths? Well, it's 7 pi fourths on my picture. No, but couldn't I put it on my picture? But I need to put it in the correct spot. So this is kind of my thought process on how I kind of, I'm going to look at this and say, I'm going to fill this in a little bit more detailed. So we're talking pi fourths, right?
Yeah.
Cutting it into fourths. Right now it's cut into halves. So wouldn't be cutting it right here, be cutting it again in half, a half and half,
Yeah.
which is a fourth, right? So this would be 1 pi fourth, right? So this is going 1 pi fourth, this is going 2 pi fourths. Look, 2 pi fourths. Do you see how that simplifies to be pi halves? So then right here, wouldn't that be 3 pi fourths? And isn't this 4 pi fourths? Isn't the fourths divide out and get pi? So then right here would be 5 pi fourths. Isn't this 6 pi fourths? Isn't 6 over 4 3 halves? And this is 5 pi fourths, right? Oh, yeah, 6 pi fourths, that's what I was going to say. 7 pi fourths. Oops, 7 pi fourths. Okay, so now we're estimating. What is our sine function at 7 pi fourths? It looks like it's about right there, right? Does everybody see how it's about right there? So that's roughly negative, right? Negative 0.8 or negative 0.7-ish, right? Okay, awesome. So I'm going to go with negative 0.7. Rough estimates are good because it's kind of hard to see exactly since we're not in tick marks and points. Does everybody see what I'm saying there? Okay, awesome. And the next one, it says 4 radians. These were pi radians. Remember, 4 radians means we don't want it as pi, but we know these are just physical values, right? We could calculate it. Pi over 4 is, look at your unit circle, we calculated these yesterday. So pi over 4's physical length is 0.78, right?
Yeah.
What is pi halves? 1.6, right? And then 3 pi fourths is 2.4 in physical length. And then pi is 3.14. 5 pi fourths in physical length was 3.9. 3 pi halves, physical length was 4.7. It's writing really small and it's squishy. And then 7 pi 6, physical length here. 3 pi halves. What am I missing? Oh, 3 pi halves. Oh, 4.7. Yeah. 7 pi fourths. It's 5.5, right? And then 2 pi was 6.2. Okay, so it says 4 radians. So let's find on here roughly where we're going to be looking for, where we're going to be looking on our graph. So isn't that between, so this is 4.7, right? And wasn't this 3.9?
Yeah.
So in between there, right? Closer to 3.9?
Yeah.
So it would be like right there-ish. So that's negative 0.9-ish, right? You see how it's almost to -1. So negative 0.9. I'm just estimating. Okay, so do you see how to do this on your sinusoidal wave? Okay, awesome. I'm proud of you. 1 through 4, go. Okay, so next thing, remember back to the very first lesson we learned in periodic functions. We learned about amplitude and then number of cycles, right? And cycles, or like, and the period means the length of one cycle. Does everybody remember back to the first day of learning periodic functions? Okay, so it says, determine the number of cycles from 0 to 2 pi. Find the amplitude, find the period. So once again, it says determine the number of cycles from 0 to 2 pi. So remember, a cycle is where your function starts, and then it starts right there again, making up one cycle. Does that make sense? So like a full length. How do I say that better?
Full cycle.
a full cycle, but I was trying to explain it without the word cycle. But you guys know what I'm talking about, right? Remember the first day, we started here, and then we were back to there, so it was a cycle, right? Does everybody get what I'm saying? Yeah. Okay, so everybody says, determine the number of cycles from 0 to 2 pi. So I'm looking at this picture. Well, the first thing I'm going to look at is, where does a cycle start and end? So I'm randomly choosing to start right here. Remember, you can draw cycles anywhere, right? But I like to start with at 0, 0. Does everybody see how I'm starting there? So I'm going to draw in with color here 1 cycle. So we're starting at 0, we're going up, down, and we're back to the starting point, right? So that's 1 cycle. Does everybody understand why that's 1 cycle? Okay, so now this is pi. So aren't we going, I'm going to change colors here. Wouldn't we, so we started again, up, boom. Isn't that a half a cycle? From there to there? So that's 1.5 cycles up to pi. So this is how I think through it. So 1.5 cycles, but that's only up to pi. So 1.5 cycles up to pi. But it said, how many cycles are there from 0 to 2 pi? So wouldn't you just do that? So pi plus pi is 2 pi, right? So wouldn't we just add those cycles twice? So that's 1.5 plus 1.5. How many cycles? From 0 to 2 pi? 3. Very good. So the number of cycles from 0 to 2 pi is 3. So you guys kind of see how I think through it. Okay. Now looking at the amplitude, that's how high up from the midline, how low down from the midline. So here's my midline, right? We're going up to 2 and then midline down to 2, right? So our amplitude is 2. And then period. You've got to remember, what does period mean? Period means the... Good. The distance. I like that. The physical length of a cycle. I like what you... Yeah, the distance, right? So it's the length, the physical length of 1 cycle. So let's look. The red was my physical length, right? Of 1 cycle. Right, everybody? So where did we end? At what value? Well, we're talking, these are pi's, right? So let's think about it. Isn't this from 0 to pi cut into 1, 2, 3 sections? So this would be 1 pi thirds, right? Right? 2, wait, yeah, let's see. So it's cut into 3, so this is 1 pi thirds, 2 pi thirds, right? And then this is, oh no, wait, this is pi right here, right? This was pi. Yeah. No, this is pi. That's pi. Okay, so we're doing right. Sorry, I'm just making sure. And then this is 3 pi thirds, which makes sense because that's pi, right, everybody? So the length of 1 cycle was 2 pi thirds. Does everybody see how I did that? Kind of tricky to think through. So the period was the length of 1 cycle from here to here, and that was 2 pi thirds. Does everybody see how to do that? These are kind of tricky to think through. We'll do another one. Does everybody understand that one? No questions?
No.
Okay. Let's do another one. All right, so looking at this one, it says, determine the number of cycles from 0 to 2 pi. So once again, there's many different ways to think through this. But first of all, looking at this, we know cycles where you start, come all the way back down, and start at that same spot. So I like to start at 0, 0. So I'm traveling up, 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 boom, I hit pi. Isn't that a fourth of a cycle? That's only a fourth, right? Because wouldn't a half be coming back here? This would be a half a cycle, right? This is only a fourth of a cycle. Right here would be a half a cycle, right? Because then if we went down and up, boom, starting here, wouldn't that be 1 cycle? So we can't even fit we can't fit a cycle on our picture, but we said from here to here was a half a cycle, right? From here to here. I'm a little bit nervous that people aren't grasping this. So do you guys understand? From here to here is a half a cycle. Well, what did we end on right there? This was pi, and that was 1, 2, or 1, 2, 3 units. So 1, 2, 3 units more. Where would we be? 2 pi. If from here to here is pi, you guys, then pi plus pi would be 2 pi. So we went a half a cycle up to 2 pi. Does everybody see that? So the number of cycles to 2 pi is a half, right? We only fit in a half. Okay. So the number of cycles from 0 to 2 pi was a half. Okay, to find the amplitude, from the midline, how far up did we go? 1, how far down? We can't see, but we can assume it would be 1. So find the amplitude, it's 1. And then the period is the length of one cycle. So we've got to really think through this. So period, I'm going to write that down, is the length of one full cycle. So let's think through this. Let's use our brains here. We went a half a cycle in 2 pi, right? Yes, let me answer your question first. Oh, you're just, okay. So I'll say that again. We went a half a cycle in 2 pi, right? We want to know the length of one full cycle. Well, that's only half a cycle, right? So we've got to go down and back up. And where are we going to be at? 4 pi. So the length of one full cycle is 4 pi. Questions? Okay, try these ones. Do 5 through 7. So now we're going to know, here is the equation for a sine function. So we're going to talk about some properties of the sine function. Very important. So the form is y is equal to a times the sine of b theta. B theta. Theta is just like an x. Okay, everybody? It's just, we're talking angles here, sines, angles, so that's why they do theta. So we have y is equal to a times sine of b theta. So a, the absolute value of a is the amplitude. Now if there's a negative in front of a, that simply just flips it over the x, right? So that will just be starting on the downward. Does that make sense? So to find the amplitude, you always have to look at the absolute value of a, meaning the positive of a. So that will be our amplitude. So if you have something multiplied in front of sine, that's how high up or down you're going. That's your amplitude. And then b is the number of cycles, but here's what's important that you remember. B is the number of cycles from 0 to 2 pi. So I'm going to say that again. B is the number of cycles you'll see from 0 to 2 pi. So then algebraically you can find the period, which means the physical length of one cycle. You can find the period by taking your 2 pi, taking 2 pi divided by b. So you'll take 2 pi divided by b, so you can know the physical length of one cycle, the period, which is the length of a cycle. So everybody, you need these things. I have to look back and say, okay, because it's just, you're thinking about so much, so you need to have this. Does everybody have it written down? Okay, write it down quick. Here we go. So, it says, sketch one cycle. You guys will write to grandpa slow. I can go back to it in a second if you need. So it says, sketch one cycle of each sine curve. Write an equation for each graph. So we're going to go through, we're going to sketch. Now notice it says one cycle. You've got to read your directions. So we know one cycle means it starts and it ends, right? That's all we're drawing. One start to an end. Okay, so it says, we have an amplitude of 2. I always start with my amplitudes, and I like to draw in kind of an asymptote for myself. So this is positive 2, this is negative 2. So we know it's going to bounce between those values. So I like to draw in a dotted line so I don't go below that or above that. Does everybody understand what you would do with something like that? Thank you. So we're bouncing between 2 and negative 2, because that's our amplitude. Now our period is 4 pi, but before I even think about that, I'm going to draw in one cycle. So drawing in one cycle would be drawing in, I'm going to start here, right? And going all the way to the top, all the way to the bottom, and back to the starting point. Does everybody see how that's one cycle? And now we're going to label our x-axis. So you've got to think to yourself, what does period mean? So period means the length of one cycle. So our full length, guys, from here to here was ending at what? 4 pi. Does everybody understand that? Okay. So I'm going to write in 4 pi. Now I need you to be a little bit more detailed. So let's cut that in half, and that would be right here, right? 2 pi. So that's 2 pi. Let's cut 2 pi in half, and where will we be? Pi. And so we're cutting it into, I cut it in half. So this is 1 pi, 2 pi, where would this be? 3 pi. And that's probably detailed enough. So let's think about this though. If I said to you, Look at it on an interval from 0 to 2 pi. It would be a really stretched out graph, right? So if we're only looking right here, we'd only be seeing the top from 0 to 2 pi. So does everybody understand that? Okay, awesome. So now let's write our equation. So we know the equation of the sine function is y is equal to a times sine of b theta, where a is the amplitude. This is the important thing. A is the amplitude, and b is the number of cycles, and here's the important part, from 0 to 2 pi. So the first part's really easy. We're going to have y is equal to a, which is the amplitude, which is 2, right? We went 2. And then we have sine of, and now b theta. Okay, so b is the number of cycles from 0 to 2 pi. So I've got to look with my eyeballs and say, how many cycles fit between 0 to 2 pi? A half, right? Or we could use the formula I gave you, which was the period is equal to, period is equal to the 2 pi over the number of cycles, right? So we can plug it in. Now we're going to be plugging in a little bit backwards, but if you see it's a half, just go with that. It is a half, right? Well, let me show you algebraically how it works. So we plug in a period of 4 pi. That would be 4 pi is equal to 2 pi over b, right? So then we're solving for b, because b stood for number of cycles. So I multiply both sides by b, so that I don't have to delta in a denominator. And then right here I have b 4 pi is equal to 2 pi. Now solving for b, I would divide by 4 pi. Divide by 4 pi. So we get b is equal to 1/2, the pi's divide out. Do you see how I got it algebraically? But do you see how you can just use your graph to look with your eyeballs? So there was a half of a cycle between 0 and 2 pi. So my b value is 1/2 theta.
Holy cow.
You can do it. I know it's hard. I do. I won't look you in the eye and say, this is easy. It's hard. You can do it. Questions? Yes.
What if it's 1?
You would just write theta, because then it goes without being said that there's a 1. Okay, let's do another one. Here we go. So it says, sketch 1 cycle. So we're going amplitude of 3, up 1, 2, 3, negative 1, 2, 3. I draw in my asymptotes. Ding, ding, ding. Ding, 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 ding. And then I'm going to draw in, because it says 1 cycle, I'm only drawing in 1 cycle. So starting here, I go all the way up, all the way down, and back to the starting point. I've now physically drawn in 1 cycle. Now the period is the length of 1 cycle. So from here to here is pi. So let's cut it in half. That'll be pi. What's pi divided by 2, guys? Let's divide it in half. Pi half. Let's divide pi half by 2. That'll be pi fourths. So this is 1 pi fourths. 2 pi fourths. Wouldn't this be? So this is 1 pi fourths. 2 pi fourths. This is 3 pi fourths. Does everybody see how to fill it in a little bit prettier here?
A little bit.
Okay. Now it says, now we're going to write our equation. So first part, we have y is equal to the amplitude, which is 3, times sine of b, which b is the number of cycles from 0 to 2 pi. So look, how many cycles did we see up to pi?
1.
So how many cycles would be up to 2 pi? 2. So let's just write that in. Sine of 2 theta. You could do it the way I showed you a second ago, algebraically, but if you can see with your eyes, that's easier, right? Okay, questions on how to do these? Okay. Okay. Oh, but it does say, oh, we already found, oh yeah, that's it. Okay. So do 8 and 9 go. Okay, so next example in here, it says sketch 1 cycle of this sine function. Pay attention. Sketch 1 cycle of this sine function. So first of all, I always write out to myself. I'm like, okay, looking at this, I know that's the amplitude. So I know my amplitude is 1/2, right, everybody? Then I know that I have 2 cycles from 0 to 2 pi. So I have 2 cycles between 0 to 2 pi. But remember, you got to read the directions. It says sketch 1 cycle. So now, the next thing I'm going to do is find my period so that I know the length of 1 cycle. Period is equal to 2 pi over b. So our period is equal to 2 pi over 2, which is pi. So the length of one cycle, so pi is the length of one cycle. So now I'm going to draw it in. Just the same as we did before. So I have an amplitude of a half, so I'm going to go 1, or let's call that a half and 1, so this is a half, and then negative a half and 1. So I have my asymptote at a half, my asymptote at negative a half. I didn't draw that very evenly, but it's the grid that matters. And then I'm drawing in one cycle. So I'm starting here, all the way up. And because that's a positive, I always start up first, so all the way up, all the way down. That's going to bug me, but that's okay. There's one cycle, right, everybody?
Yep.
And then we know the physical length of one cycle is pi, because our period is the length of a cycle, right? So I know this is pi. So I'm going to do that divided by 2 to be more detailed now. So pi halves, and you'll say, okay, pi halves divided by 2 is 5/4. And then this is where I always, so it's easier on myself not to have to say, well, what's between pi halves and pi? I go 1 pi/4, 2 pi/4, 3 pi/4. And now I pulled it in detailed enough. Does everybody see what I'm doing here? Yes, I want it this detail at least. One more. Quick. People, stay with me. So my amplitude is, don't call it -3 because it's the absolute value of -3, which is 3. So we're going up. I'm just going to go 3. -3. Draw in my asymptote. Dang nabbit. Why did it just go crazy? Just a sec. So my asymptote, sorry, finishing that out. Okay, so then my period, my length of my B value is the number of cycles from 0 to 2 pi, right? 0 to 2 pi. So that's, well, Mason, good question. What is this the same thing as? Isn't that the same thing as 1/2 times theta?
Yeah.
So let's think of it that way. So the number of cycles from 0 to 2 pi is a half. So I need to know what's my period, which means the length of one full cycle. So remember, period is equal to 2 pi over B. So plug it in. This is B. So we have period is equal to 2 pi divided by 1/2. Now you've got to be really careful. Take your calculator. Type in 2 divided by parentheses 1/2. Or you could say dividing fractions is as easy as pi. Flip a second and multiply. What do you get? 4. Very good. So the period is 4 pi, which the length of one full cycle is 4 pi. We took 2 divided by 1/2, we got 4. So 4 pi. Does that make sense?
Yeah.
Okay, so now we're drawing in one cycle. So ding, oh crap, pause. See, I've already messed up. See the negative in front? That just means it flips it the other way, over the x-axis. So instead of dipping up first, we've got to dip all the way down, all the way up, and back to the starting point because of the negative. Flips it over the x-axis. So then from there, we know the full length of the cycle is 4 pi. So this is 4 pi. So then cutting that in half is 2 pi. Cutting 2 pi in half is 1 pi. So this is 1 pi, 2 pi. This would be 3 pi. That's as detailed as you need to get. We all comfortable with these. Okay, I need you to do 10 and 11. Next one here says, find the period of each sine curve, then write an equation for each sine function. So we're finding the period of each sine curve, and then write an equation for each sine function. So remember that the equation of sine is y is equal to the a times the sine of b theta, where a is the amplitude and b is the number of cycles from 0 to 2 pi. So I kind of like to start these out by drawing in one full cycle. So right here, I like to start at 0, right? Now notice we're dropping down first, right? So we're definitely going to have a negative. We can't forget that. So we drop down, up, and back here. Isn't this the new starting point? Yep. So we've got to figure out where, because that's the length of one cycle. We need to know the length from here to here. Okay. So let's see. So right here looks like pi, right? Okay. So this was 1 pi. What's this?
1 pi.
From here to here is 1 pi, so from here to here is 2 pi. So the length of my cycle is 2 pi. Okay, interesting. Then also, my amplitude is, here's 2, this is 3. Okay. So I know that my amplitude is 3. I know that my period is 2 pi. So now it says, so we need to know the number of cycles from 0 to 2 pi. So you can either use your picture or use that formula and kind of work backwards. I'm just going to use my picture. From 0 to 2 pi, crapola. From 0 to 2 pi, I'll get that plugged in. How many cycles did we have? 1. So won't our b value be 1? All right, so our b value was equal to 1. So we will go ahead and write it. Y is equal to, because it drooped down in the negative direction, -3 sine of 1 theta. So I'm just going to write theta.
Is it beta or theta?
Theta, theta. There is a beta, but that's a different Greek symbol. But yeah, it's not that. Yeah. Okay, one more like that. Okay, I need to plug in my computer though. Okay. Okay, so once again, find the period of each sine function, sine curve, and write an equation. So the first thing I like to start out with these is drawing in 1 period, which means 1 cycle, right? So I'm going to draw in 1 cycle and see where I stop. Ding, ding. Okay, so we know that that's the physical length of 1 cycle, which was at pi thirds. So our period is pi thirds. Interesting. And then our amplitude is half. So our amplitude is 1/2. And then my number of cycles between 0 and 2 pi. You can either look at it or use the formula. So number of cycles. We need that for b, right? We need our b value. So with this one, I'm just going to use the formula. So I know it's period is equal to 2 pi over b. We're solving for b. We have the period. So I go pi thirds is equal to 2 pi over b. Right, everybody?
Yeah.
Then I don't want b to be in the bottom. So I'm going to multiply both sides by b. The b's are gone, right? Then I'm going to divide by pi thirds. So I have b is equal to 2 divided by 1/3, right? You got to type it in right. If you do that, or you could say, dividing fractions is easy as pi, flip the second fraction and multiply. So you get 6. And then our pi's, because we're going to flip the second and multiply, the pi's will divide out. So b is 6. Does everybody get how I did that? So I know that my equation is y is equal to, it went up, so not a negative, 1/2 sine of 6 theta. There were 6 cycles from 0 to 2 pi. Or you could have thought of it like this. How many pi thirds are there in 2 pi? 6 of them, right? Okay. So do 12 and 13. So we're going to finish off the front of the worksheet today. Don't cross out the back. We're going to finish that up tomorrow, but I need you to finish 12 and 13 today.